Hello friends. So in this class, we are going to solve a question paper. Okay, this is IBDP question 81. International Baccalaureate Organization 2023. Diploma Program IBDP. Okay, so Physics Higher Level Paper 1. Okay, come to the first question. What it tells? The first question is the ratio of the diameter of an atom to the diameter of its nucleus is diameter of an atom. So diameter of an atom is approximately, I'm writing here, diameter of an atom is, what is the order of diameter of an atom? 10 to the power minus 10 meter. And what is the diameter of nucleus? Diameter of nucleus. Its nucleus. That is 10 to the power. Order of magnitude is 10 to the power minus 15 meter. So we have to find the ratio. Means 10 to the power minus 10 meter upon 10 to the power minus 15 meter. When we will solve it, we will get 10 to the power 5. So our answer will be C, 10 to the power 5. The kinetic energy of a body is determined. The kinetic energy of a body is determined from measurements of its momentum P and its mass M. The percentage uncertainties in the measurements are: in momentum, the uncertainty is plus minus 3%. In mass, it is plus minus 4%. So there is a relation between kinetic energy and momentum. What is that formula? EK means kinetic energy equal to P square by 2A. So if you have to find the percentage error in this, means delta EK upon EK is equal to, because this is a square, so this will be 2 delta P upon P plus delta M upon M. Okay. So 2 into delta P by P in percentage form, it is 3%. So 2 into 3 plus delta M by 4. So 2 into 3, 6 plus 4. This calculation is in percentage. So 6 plus 4 is 10%. Okay, remember, it is in percentage. So 6 plus 4, 10%. So answer will be B. Then come to the question number 3. A car travels clockwise around a circular track of radius R. Okay. A car travels clockwise. The car is traveling clockwise around a circular track of radius R. What is the magnitude of displacement from X to Y? So this is the X position and this is the Y position. Okay, means this is the initial position, this is the final position. So what is the displacement? Final position minus initial position. So displacement, what is the definition for displacement? Final position minus initial position. Position minus initial position. Okay. So final position is this, initial position this. Just connect this line. So we have to find this length. Okay. So what is the radius here? R. So this is also R and this is also R. Isn't it? This length is R This length is also r. So we have to find this. So by the Pythagoras we can find. So xy is equal to r square plus r square root. It means that is root of 2r square. Means root 2r or r root 2. Okay, r root 2. So this will be the answer. C is equal to r root 2. Okay, because displacement is this one. This xy. This is the displacement. Okay, fine. Come to the next question. A stone of mass m is projected vertically upwards with a speed u from the top of a cliff. The speed of the stone when it is just about to hit the ground is v. So what is the magnitude of the change in momentum? So change in momentum is equal to final momentum minus initial momentum. Change in momentum equal to, always write this formula, final momentum minus initial momentum. So what is the initial momentum? Mu. What is the final momentum? So this is upward direction. So this is plus mu. This is downward. So this will be minus mv. So final momentum is equal to minus mv minus initial momentum is plus mu, isn't it? Because it is in the upward direction. And this is final velocity is in the downward direction. So minus. So ultimately, this is minus mv mu. So is equal to minus m, that is v plus e. Okay. Now, what is the magnitude? So magnitude is only m into v plus e, isn't it? It is asking about only the magnitude. So magnitude is the only we have to take the magnitude. That is the positive. So that is m into v plus u. So this is C is the correct answer. Come to the next question. A car accelerates uniformly. The car passes point x at time t1 with velocity v1. So here, what is the velocity? v1. Car passes point x at time t1. So here the time is t1 and velocity is v1. Here at y, the time is t2 and velocity is v2. So the following expressions are proposed for the magnitude of its acceleration. So what is acceleration? Acceleration is the rate of change of velocity, isn't it? The rate of change of velocity is the acceleration. So acceleration is equal to v2 minus v1 upon v2 minus v. Okay. So this one, this is correct. Another one is also we know that from the equations of second equation of motion, v2 square minus v1 square is equal to 2as. Already we know. It means A is equal to V2 square minus V1 square upon 2s. So this is also correct, isn't it? So A and 2 and 3 are correct. So our answer will be C. This will not satisfy, okay? Because the another equation, the third equation of law of motion is what? That is S is equal to ut plus half at square, isn't it? So this equation will not satisfy this. So that this will not be. So these 2 and 3 is correct. A ball attached to a string is made to rotate with constant speed along a horizontal circle. The string is attached to the ceiling and makes an angle theta degree with the vertical. The tension in the string is T. Tension in the string is T. So what is the correct about the horizontal component and vertical component of the net force? We are talking about the net force. So this is the tension. Okay. If this is the ball, so its weight mg will act downward, mg. And this is theta. So this will be 90 minus theta, isn't it? And this is 90 degree, right angle. This is T. So this T will have two components. One component in this direction and one component in this direction. Okay. So this component will be T sine 90 minus theta. This component will be T cos 90 minus theta. Correct? Now this T sine 90 minus theta, because there is no motion in the vertical direction. So this will be balanced by this. So this will not count for the net force. Only this one count. Net force will be this one. This is in the horizontal direction. Okay. So horizontal, what is the fact? T cos 90 minus theta. And we already know that cos 90 minus theta is equal to sine theta. So that will be T sine theta. Okay. And here, because mg equal to, this is T sine 90 minus T cos theta. So net force in the vertical direction is what? 0. And net force in the horizontal direction is T sine theta. So T sine theta and 0. So D will be the correct answer. Horizontal component is T sine theta and vertical component is 0. Next, a block of mass 2 kg is placed on a trolley of mass 5 kg moving horizontally. A force of 8 Newton is applied to the block which slides on the surface of the trolley. The frictional force between the trolley and the ground is 0. So here this 8 Newton force is being applied here. The trolley accelerates at a rate of 1 meter per second square. So what is the coefficient of dynamic friction between the block and the trolley? So here this is the block and the trolley. So here we have to find the coefficient and friction. So this is here, this is friction. Okay. So here this trolley is moving due to the frictional force. So what will be the frictional force here? This is the weight of this. So this is acting downward, isn't it? A block of mass 2 kg is placed on a trolley. So the weight will be 2g. Okay, mass is 2. 2g means if we'll take g is equal to 10 approximately, so 2 into 10, that is 20. Coefficient of dynamic friction. So what is the friction force? F is equal to mu d into n. Here the weight is acting downward and normal direction is acting in this direction, n. Okay, or r, sometimes we call it by r, normal direction. So what is normal direction? Normal direction is going to be 20 n. Normal reaction R is equal to 20 Newton. Okay. So we can write it here. F is equal to. Now this is the frictional force between the trolley accelerates at a rate. This trolley accelerates at a rate of acceleration is what? 1 meter per second square. Correct? What is the mass of the trolley? 5. So what is the force here? This force, capital F, you can say. Capital F is equal to what? MA. Mass of the trolley and acceleration of the trolley. So mass of the trolley is 5. Acceleration is 1. So this is 5 Newton. Okay. So this motion is only due to this frictional force. Now, so both will be same. So F is equal to capital F. Frictional force is equal to F. What is the frictional force? 20 Newton. What is this force? Mu d n, or some we can call it mu d r also. So mu d into 20. F, this F is equal to 5. Okay. So we'll let it here. This F is equal to what? 5. And for this F, we can write mu d into 20. Into 20. So mu d is equal to, means dynamic coefficient of friction is equal to 5 upon 20. That is 0.25. So answer will be 0.25. This is correct answer. Okay. Then come to the next problem. The input power of an electric motor is 200 watt. It is used to raise a mass of 10 kg at constant speed. If the efficiency of the motor is 40%, through what height will the mass be raised in 1 second? So 200 is the input power. Okay. What is power? Power is the energy per unit time. Here also it is asking per second. Okay. So this is 200 watt is the input and 40% is the efficiency. Then output will be what? Useful output will be 40% of this 200. That is 0.4 into 200. So that will give you 80. Okay, 80 watt. So this is the out or useful work or useful output. That is 80 watt. Okay, and it is used to raise a mass of 10 kg at constant speed. If the efficiency of the through what height it will find. So we can find now this is equal to what? mgh. This output means 80 watt is equal to m into g into h. Okay. So 80 equal to what is m here? 10. G is equal to 10 we can take. This is h. So what is h? H is equal to 80 upon 100. That is 0.8. So 0.8 meter is the correct answer. Next, we'll make little space here. Okay. The temperature of an object is changed from theta 1 degree Celsius to theta 2 degree Celsius. What is the change in temperature measured in Kelvin? Okay. So if it is, if the temperature is theta 1, so when we convert it into Kelvin, so it will become theta 1 plus 273. When we will convert this theta 1 degree Celsius, this will be in the Kelvin. And theta 2 degree Celsius, when we will convert it, this will become theta 2 plus 273 Kelvin. So when we take the difference of 2, it will be ultimately theta 2 minus theta 1 only. So there is no difference in the temperature. Difference in temperature will be same for the degree Celsius and Kelvin scale, both. So theta 2 minus theta 1 is the correct answer. Okay. Now question number 10. A metal cube X of length L is heated, gaining thermal energy Q. Its temperature rises by delta T. And a second cube Y of length 2L made of the same material gains thermal energy of 2Q. So what is the formula for Q? Q is equal to what? M C delta T. Isn't it? For the first case. The second case is equal to what? 2Q is equal to, now this is M, and for this, if now how the mass and length is related. So just see here. So mass is equal to density into volume. And for volume, we can write rho. What is dimension for this volume? L cube. Density is constant. It means mass is proportional to L cube, cube of length. Okay. So mass is proportional to L cube. This relation we have to remember. Mass is proportional to L cube. Okay. So here, if it is mc delta t, so that you can write that is your rho into L cube into C delta T we can write, isn't it? For this, it will be rho into 2L to the power cube into C into, for this we can write 2 cube, this is equal to delta. If this we are writing it is delta T1 or delta T, here it we can write delta T2. So from here, what we find? That is, this is 2 cube. So this will be 2 cube is equal to rho into this is 8L cube into C into delta T2, delta T2. Okay. So from here we can find it. That is, after cutting, we'll get that 4 rho L cube C delta T. So that is that will be delta T upon 4. Q upon delta T upon 4. Okay. Answer will be, because when we will convert it delta, what is the temperature rise of Y? So delta T will, delta 2 will be delta T2 is equal to delta T upon 4. Delta T2 is equal to delta T upon 4. Okay. So in this class, we have only solved 10 questions. In the next class, we'll solve the next 10 questions. Then in the third class, we'll solve next 10 questions. So we are doing this because we don't want to make a longer video. Okay. So we'll stop here. In the next class, we'll solve the next 10 questions. Okay. Similarly, we are going to solve the questions of all types.